I am Nandakumar. Today we are discussing about the topic of system design and implementation. This topic under the understanding the principles, architecture and best practice. This is the topics we are going to discuss today. What is system design? System design is the process of defining architecture components and modules of a system. It involves planning, organizing and implementing solutions based on requirements. Helps in developing efficient, scalable and maintainable systems. Includes both high level and low level design process. Important for ensuring system reliability, security and flexibility. Used in software development, embedded systems and large scale applications. Why is system design important? Ensure scalability, allowing the system to handle growing data and users. Improve performance by optimizing data flow and resource allocation. Enhance security by incorrupting authentication, encryption and threat management. Reduces system failure through proper fault tolerance mechanisms. Provide better collaboration between developers, designers and stakeholders. Help in efficient debugging and maintenance after deployment. Next one is types of system design. First one is architectural design. Focuses on overall system structure and communication. Determines how different models and service interact. Example: client server, microservice, layered architecture. Next one is logical design. Defines the flow of data logic processing. Include entity relationship diagrams, ERD, data flow diagrams. Physical design. Specifies hardware and network requirements. Includes server configuration, data storage and cloud solutions. Determines how data is stored and retrieved efficiently. Next one is key principle of system design. Scalability. Ability to handle increased workload without performance loss. Maintainability. The system should be easy to update, debug and modify. Modularity. Breaking down the system into smaller independent modules. Next one is security. Implementing authentication, data encryption and secure APIs. Efficiency. Optimizing system resources like memory, CPU and storage. The next one is fault tolerance. The ability to recover from failures without crashing. Next one is system design and its goals. Introduction to system design. The system design is the process of defining architecture, components, modules, interface and data for a system to satisfy specific requirements. Goals. Scalability. Ensure the system to handle growth, reliability, minimize failures and ensure fault tolerance. Performance. Optimize response time and efficiency. Maintainability. Make the system easy, update and modify. Security. Protect data and prevent vulnerabilities. Next is implementation of mechanism. Mechanism of system implementation. Key mechanism is system implementation. First one is architectural selection. Monolithic, microservices, layered, etc. Technology stack, programming language, frameworks, database. Development approach. Agile, DevOps, waterfall. Testing strategies. Unit testing, integration testing, system testing. Deployment methods. On-premise cloud-based hybrid. Next one is design policies in system development. Policies for effective system design. Design principles. Separation of concerns. Divide the system into independent components. Modularity. Design reusable components for better maintainability. Encapsulation. Protect internal detail and expose only necessary functionality. Loss coupling and high cohesion. Reduce dependencies for flexibility. Implementation policies. Version control. Use Git for tracking changes. Code review and documentation. Maintain high code quality. Security policies. Implement authentication, encryption and access controls. Next one is system architectural types. Monolithic architecture. All functionalities in single system. Used in traditional applications. Microservice architecture. Independent service communicating via APIs. Used in modern cloud apps. Client server architecture. Server provides resource while clients request them. Used in web application. Peer-to-peer P2P architecture. Direct communication between nodes without a central server. Layered architecture. System is divided into layers, presentation, business, logic, data access. Event-driven architecture. Components react to real-time events, improving efficiency. The next one is high-level Design HLD provides an overall system architecture overview, describes major components and their relationships, focuses on data flow and system communications, does not include detailed module level implementation, helps stakeholders and developers understand system structure, typically represented using block diagrams and flow charts. Next one is low level design LLD, provides detailed components level architecture, includes module specification, algorithm and database schemas, define class structures, functions and interactions, helps in writing actual implementation code, ensure that all components follow HLD specifications, commonly represented with UML diagrams, sequence diagrams and ER models. Data flow and management. Data flow diagrams DFD help in visualizing how data moves within the system. Proper data storage ensures fast retrievals and efficient queries. Database normalization prevents redundancy and ensures consistency. Indexing and caching improve performance in large scale systems. Backup and recovery strategy prevent data loss. Security measures like encryption and access control protect sensitive data. Security consideration. Authentication. Verify user identity, user passwords, OTP, biometrics. Authorization. Defining access control using roles and permissions. Encryption. Securing data in transit and at rest. Secure APIs. Implementing OAuth, JWT and SSL or TLS for safe communication. Threat mitigation. Preventing SQL injection excesses and DDoS attacks. Audit logs. Keeping track of system activities to detect anomalies. Next one is scalability and performance optimization. Horizontal versus vertical scaling. Adding more server versus increasing server power. Next, load balancing. Distributing traffic to prevent overload. Caching strategies. Storing frequently accessed data for quick retrieval. The recently used data is stored in the recent column, that is used to for quick retrieval, that is caching strategies. Next one is database optimization. Indexing, sharding and query tuning. Next one is asynchronous processing. Using message queues and background jobs. Monitoring and auto scaling. Adapting resources based on demand. Next one is implementation strategies. Agile development, iterative approach with frequent updates, waterfall model, sequential process for well-defined requirements. DevOps integration, continuous development, testing and deployment. Microservice development, independent service running separately, CI or CD pipelines, automating build test and develop deployment process. Version control using Git for collaboration and rollback capabilities. Testing and debugging. Unit testing, testing individual components. Integration testing, ensure module compatibility. Performance testing, checking load handling and response. How the program is work and what are the performance is going to move on. Speed and accuracy is the called performance testing. Next one is security testing, identifying vulnerabilities. Next one is regression testing, ensuring changes do not break existing features. Automated versus manual testing, choosing the right approach. Deployment strategies. One premises deployment, hosting on company owned infrastructure. Cloud deployment, using AWS, Azure or GCP. Hybrid deployment, a mix of non-premises and cloud hosting. Rolling deployment, gradual release with minimal downtime. Blue-green deployment, running two versions to avoid service interruption. Containerization, using Docker and Kubernetes for scalability. Case study, how Netflix, Amazon or Google handle scalability. Netflix, Amazon and Google primarily achieve scalability by leveraging cloud computing services like Amazon Web Service (AWS), which allows them to dynamically adjust their infrastructure based on user demand. Adding or removing services are needed to handle fluctuating traffic volumes, ensuring smooth performance even during peak usage periods. This is often achieved through features like auto scaling and distributed system architecture across multiple data contexts globally. Key points about how these companies handle scalability. Microservice architecture. Breaking down application into smaller independent service allow for individual scaling of components based on their specific needs, improving overall system flexibility and resilience. Next, content delivery networks, CDNs. Distributing content across global network of servers bring content close to user, reducing latency and improving delivery speeds, particularly important for video streaming services like Netflix. Actually, horizontal scaling, adding more servers to cluster to handle increased load rather than relying on a single powerful server, which is a core principle of cloud-based scaling. Specific examples: Netflix and AWS, Amazon and AWS, Google and Google Cloud Platform. The conclusion is system design is critical for building scalable and maintainable software. Following best practices ensure efficiency, security and reliability. Different architectures suit different business needs. Design patterns help structuring and optimizing systems. Implementation strategies must align with project goals and constraints. A well-designed system leads to better user experience and business success. Thank you guys.